Welcome everybody, you're watching Mr. Fugu Data Science. Today is a continuation of the Russian troll tweets. If you haven't seen the first one, click the card above and check that out. Today we're doing exploratory data analysis and a bunch of plots. This is allowing us to finish up on getting a handle of what our data are actually doing to help dictate how we should investigate natural language processing and what we should probably do. Feel free to hit me up here on Instagram and Twitter, and if you would like to help support the channel, here's my Patreon as well. Consider to buy me a coffee, and there's the handle. I want to mention something first. From the last video at the end, I had this highlighted portion that's actually unnecessary, and it wasn't giving me the correct printout for, I think it was one of these two tweets that had an additional double quotation inside of it after I did that. So I decided, well, let's try to fix it with doing a strip technique, and that wasn't helping me. Doing a chain together strip, so I did a replace, and that took care of what I needed to do. That's the addendum that I had to finish at the end. That code is on my GitHub as well as today's. I also want to say thanks to the recent subscribers and viewers. I greatly appreciate it, and the person who contacted me yesterday asking me to go a little slower in some of my videos for those who are learning. Thanks for the feedback. Here's the first imports that we're going to use today. Stop the video and use those. It's pandas, numpy, matplotlib. These are the data that I fixed from last time, where we took out the hyperlinks from the tweets, because later we're going to do in the next video natural language processing. Today, EDA and plotting. I'm only going to use the English language today because translating hundreds of thousands of these rows are a problem with the Google API. It's not free. It's only free for a certain amount of 200,000 entries or something like that per day, and dealing with making the function calls, it just keeps messing up for me. So I decided I don't want to do the paid version. If anyone has a better technique that's free and fast, let me know. The way that we subset these data is like this. We first call the column that we're interested in here, then we do a double equals and take the English rows, and then we throw it into the data frame, and let's see what this looks like. I'm going to go step by step and kind of slow today, because I feel that that's probably going to help people a little more, showing what the code's actually doing than explaining it. So if you notice, all of these rows are English, and we're going to also need to subset these by dates. So we need to do some date time formatting, which is going to be important. I noticed from last video we had a problem. I forgot to address this. I need to do some lowercase for the right and for the left so we can coincide with these uppercase versions of each of them. And to do that, I just said, let's do a map function and take care of all of the names of those strings, convert them to lowercase. Just replace the values in the account type column with our new values, and then print out, for sanity's sake, the unique values so we know what they are. But we notice that they're saved. But we get this goofy kind of an error, and it's because of the way that I'm doing this. You can read the documentation. It wants me to do a .loc, but I'm not really concerned with that. So instead, I'm going to show you an error handling to deal with this. To get ready to do some plotting, we need to do some date time formatting. So we call that in, and here the highlighted portion pd.setOption allows us to deal with that error message from above. Where I have none, there's parameters you could put here. I'm not sure what they are because I'm new to this one, but you can look at that in the documentation. Let's do this so we can go line by line and see what's going on. So we can see that we're dealing with the string here. Okay, that's fine. That means that we have to convert this into a datetime formatting, which is what I did here. And I did an inferred datetime format equals true. This runs kind of slow. And the problem is that I have, like 2 million rows or something like that. I could have ignored this, but I wanted you to see this option. Then what we could do is we could print this out and see what it looks like. It's going to take a second to run. So we scroll over, and it looks the same, right? But let's do this. And you'll see this. This means that it's now a datetime formatting. Perfect. But let's notice something else. Hold on. These aren't formatted in ascending order. So that's what this is doing here. So we'll put it in ascending order. Perfect. Now we're at 2012, which is what we want. This is going to help us later for the plots. I'm taking out the time stamp, which is this, and I'm going to only take month, day, and year in the American format, but it'll be changed later, you'll see. But you'll notice that we have this date time.string f time, which is part of this. I just put it on a new line. There we are. So we got our published date, but now we scroll over, now we got our new one. But this one is actually string formatting. For these dates, I wanted to emphasize what was going on around the time of the elections, a little before, a little bit after, to show you what it looks like for the time series of the tweets. That's why I took this right here. This is the date range that we have. Notice the parentheses that I did for each of those, as well as the ampersand. I threw that in to take those columns, the columns for the published date, and extract every row that fits in that date range. Then I sorted those values. So we can look at that real quick. So here's what it looks like for our date values. Perfect. So this works. Then the next thing I did, converted this into a date time again, and I got us ready for our matplotlib. Notice this .pyplot, you'll end up getting an error if you don't use that for the labels that we throw in here. So I'm doing a pretty big figure size. And then if you notice this, when you do the value counts, it's going to take the column for this date and it's going to count every occurrence that it sees of that date. We can look at that real quick to make it clear. So here we are. So now we have a simplified list of all these days. I think it's 100 days or something like this. And here's all the tweets by those days. These are going to be important, and we're going to do a plot with this later. We're able to sort these days right here, and then we got this sort index. So what that's doing is this would be our column, and these are the index values. That's what we're sorting by, is this index, and plotting it out. I took the X tick marks and I just rotated them and shifted the labels. Then I created the title, the X and Y labels, as well as their sizes, made a good formatting, and printed it. I did the dot show so you don't have that goofy little line that comes up after the fact. Or not line, but a little message. So we're from September 2016 to January, around the 1st, if I'm correct, of 2017. On the y-axis, we're looking at the number of tweets, and you see this huge spike. That's pretty prominent, and there's something interesting to mention with this. Around this day and the day before, there's some interesting things that happened with President-elect Trump, since this was before he got into office for the first term. He met with the Mexican president, was talking about the border walls. He also was making a lot of disparaging comments against Hillary Clinton. A lot of people on Twitter started tweeting a lot of things. That's this spike right here. There's some other stuff that was going on in this time frame. So we're going to look and investigate this spike, and you'll see the election is around here. There's another little small spike right after the election when he won, which is this. Here's a source for the information, and this plot is adapted from this person on Kaggle. Now let's investigate that spike where we're subsetting our English. We're using the subset English language. Here's the date range that I was interested here, from the 1st to the 14th, 2016. And these are the number of tweets that were in that date range. So it's pretty significant. 2 days with quite a bit of tweets, which is really interesting. What I did here was do that same formatting of subsetting our rows and chuck that in here. And then I sorted by the dates. Same exact thing I did above. And then I converted it into the timestamp and did a value count on it here. Exactly the same I did above. I just changed the date range. Okay, but what about the groups of trolls who tweeted these days? That's what we're really interested in. Remember, this is the English subset. There's a plot that I'll have, which is for Russians, and another plot, which is the whole data. This specific plot is relative to the October 7th, 2016 tweets. We subset just for that particular day with this conditional equal parameter. And then this is really easy, because what I did was, after I stored this variable of October 7th, then I wanted to know, I want this specific column of category, account category, because this deals with the type of trolls that we're tweeting. And then you just do that value count, because the value count takes anything relative to whatever column you are and counts every occurrence it sees of each one of those unique names. And you just do a dot plot directly on your data frame, and it gives this crude little plot here. And this is what we'll notice for October 7th. We had 6,000 tweets and some change for the left trolls. The right trolls is around, 2,500. And then it just goes down, but it'll let you know that the right trolls and the left-leaning trolls are the highest proportion or highest proponents of our tweeting information. Doing the same exact thing for October 6th, just changing this date here and cutting and pasting everything else and changing this date, we're going to see a big change. We see that there's more than probably 12,500 left trolls, and then there's a little over 4,000 right trolls, which is crazy, because the day after, it's half of this number. So there's definitely some things going on in the media. What's interesting is this is all tweets in English. I don't know what was going on in the Russian media, but let's do a comparison real quick. I extracted all of the Russian tweets. I pulled out the publishing date and converted it to date time again. I sorted the values. I converted it by month, day, year. This is cut and paste from what I did above for the English. So that's all you had to do. I take out the same date range once again, sort all of those. I take that date and convert it into a date time instead of a string. And here's all of our Russian troll tweets. Then I do a plotting with a cut and paste of the exact same as above. I just changed the name here. So we're basically taking this column, a published date only, which is the month, day, year, doing a value count for each occurrence of each date. Then I sort by the index. The index is the date when you do a printout of this. And then we just plot it off. And we'll notice a far significant difference of actual tweets that were done. But still, you notice in this date range from a little after the 1st of October to roughly, I don't know, midway October, a little after midway October, you have this huge spike right here, which is very significant. Kind of coincides with what's going on in the English tweets. But there's an issue. We don't know what's going on in the Russian media. We don't exactly know what's going on with these tweets unless we translate them. Therefore, we can't exactly say that those two correlations coincide with each other. So be careful with making that statement. Let's zoom in and take those dates of interest and look at the 2nd to the 11th of those troll tweets from Russia. We do a cut and paste of what we just did from above. Same exact thing. We take the subset dates, we sort the values of the dates, we convert it into date time, then we start doing our formatting for our figure size, and we do the value counts of the month, day, year, and sort by the index, which is your date, plot it off. And you notice that between the 6th and 7th, we do have a steady increase, not as much as the one we had from the English ones, but then from the 7th to the 10th, you have this really big peak. So obviously something was going on at that time. Now let's plot everything in regards to followers and following to see if there's any correlation, or if there's something we could see any trend. This was adapted from the same person, this other particular plot on Kaggle. What's going on here is this kind of simple code. You call in your Seaborn. Your X is your followers, your Y is your following, and then you're coloring based on the account category, which is the type of troll. And then you just call in the whole data set and it plucks those out. And the rest of the stuff is the labels. So if we look at this real quick, we can see that here's the legend for the type of trolls, and you'll see that there's these big old numbers of people that have a lot of following and they have a lot of followers, and those are the right trolls. The right trolls tend to have a lot of people who have similar numbers of following versus followers in proportion. We could also see that the left trolls, which is this right here, this red one, I'll put an arrow for you guys. This one shows that it's steadily increasing, and then it's pretty flat for the green one, which is the non-English tweets, which seems like they're not following a lot of people, but they have a lot of followers, which is kind of dubious. Maybe it's a business entity, who knows. Let's evaluate the top 10 users, the top 10 people who are throwing these tweets. Here they are, and see what we could investigate from this. I did this value count, which gives us that table, and then I took the index values, which gives us the names as that we convert into a list. And that's what I did with this right here. I converted it into a list. And then I took the particular columns of interest for us to do our plotting coming up. And then I did this interesting thing it saves me from doing looping, which I almost did. But it's really convenient because now I could take this particular column of author, this index of the specific names which are going to be in the rows, and only extract those. This is really interesting and very helpful to have if you're doing subsetting, because it allows me to use this column and then this list of names and pull out any rows with that, which is perfect. Exactly what I needed. So here I decided to take the max value, because when you're doing this, if you do a sum, that's the wrong operation. You don't want to do that. You're going to have fluctuations between each publishing date. You may have multiple times during the day where it changes followers or following for the Twitter person, and you don't want to use the sum because that's incorrect, and you don't want to do the average. So instead I said, well, what was the max value they had for the day? I could have did the minimum, but I chose the max. This is a multi-level table. These upper ones for follower and following, those are your columns. These two down here are your indexes. So you got to pay attention to that. So anytime you do that group by, you need to have some kind of statement, sum, count, min, max, etc. if you've never done this before. And I always sort by the days. Also, not each one of these users had a follower following for each one of the days. So that kind of threw me off, and I had to rethink how I would set this up for plotting and make it simple. So I converted this into a list so we could read in these names and recreate a data frame from this nested table or multi-level table we had above. I couldn't figure out an easy way to flatten it out simply. This isn't something I do every day, but I just converted it into data frames like this, and then I concatenated everything together by columns, so it just expands it wide. And then we start doing our plotting. And since it was using the Seaborn, this made it extremely easy. And we're going to do two plots. One with the followers, the other with following with respect to the author, which is going to help us with our coloring and our dates. And the rest of this is just matplotlib doing your labeling and legend information. And this is allowing you to move the legend outside of the plot, since here it's going to look ugly and it doesn't really have a place to go. So here's our legend with respect to the top 10 people who are tweeting at this particular time frame here. And you notice that the amount of followers isn't really changing. There's not a lot of changes. There's like a few slight gradual increases for some of these, two of these users, it looks like. But you're going to notice drastic changes with people who are following. Doing the same exact thing, but changing this particular column for your Y and cutting and pasting everything else, we notice these really interesting changes with some of these people. Right before the election, you see a pretty good increase right here. The range right here for the two large numbers of tweets, I don't see really big volume changes. I just see the trend coming up to the election here with the groups of people following each other. Next video, we need to decide what do we want to do for the NLP. Are we doing word clouds? Yes. What kind of analysis are we going to do? Well, that's going to be a little bit of a surprise. There's a few things we're going to look into, as well as some other plotting techniques. But we're going to show cleaning, how you clean this kind of data, as well if you've never used natural language processing. But as always, I like to say please like, share, and subscribe. And if you subscribe, turn on that notification bell. Feel free to help support this channel. There's my Patreon once again. And also another option, consider buying me a coffee. But as always, I'd like to say thank you for watching. See you in the next video. Bye.